Hello, welcome. Today let's try to solve a Leetcode problem 1353, maximum number of events that can be attended. So we are just given an array of events. Inside the array, just means the start time and end time. We are going to return the maximum event we can attend. But for each day, we can only attend one event. So for example, on day 1, we can only attend the event from day 1 to 2. For day 2, since this event is finished, we can attend the event from day 2 to day 3. And on day 3, we can attend the event from 3 to 4. Or on day 4, we can attend the event from 3 to 4. But the maximum you can attend is only 3. Now let me analyze the problem in the whiteboard. After that, I'll code it up from the code editor. So let's analyze this kind of a problem. So for the events, there are just random events. There are start date and end date. It can be any kind of a different event. Normally for solving this problem, I'm considering sorting the array, like for the start time, or sorting the array according to the end time, but actually that didn't work. I tried some more testing cases. It never works because there's always edge cases. Now, for example, if we start the event as the start time, for example, this is 1 to 2, and this is maybe this is 1 to 5 maybe, and this is 2 to 6, and this is 3 to 7, and this is let me prepare another one. This is 2 to 6, and let me just prepare more. So we still have 2 to 6, 3 to 7, and maybe 3 to 8. If our events are like this, we are just to start from the start time. Like from day 1, we can attend the first event, or day 2, we can attend the second event, or day 3, we can attend this third event. And on day 4, we can still attend this event. But the situations may be not like this. Let me draw some other cases. But there are other cases for the event. Let's prepare the event. For example, it is like 1 to 2, 1 to 2, and 1 to 3, and 2 to 4. If we are sorting according to the start event, so if it is here, we just check it. So for the day 1, we can finish this event. So what about the day 2? We can also finish this event. So what about day 3? We can still finish this event. So or day 4, we can still finish this event. So there are a lot of edge cases. So this is why the greedy is really difficult to think. While we are coding, we may find a lot of bugs about this kind of edge cases. But for now, I cannot find more edge cases. Let me think about another way. Maybe maybe we have a lot of 1 to 6. This is a 1 to 6, and this is also 1 to 6. Day 1 to day 6, and here is 1 to 2. And this is a 1 to 2. Let's just prepare this 1 to 6. So we have the event of 1 to 6. It means that we have many events of 1 to 6. And we still have another event of 1 to 6. So normally how should we finish this event? Or day 1 we can finish this event, or day 2 we can finish the second event, or day 3 we can finish the third event. Would we have an event of, for example, 2 to 2 to 3, 1 to 2 to, let me make it 2 to 3. If on day 3 we finish the third event, this one, day 1, day 2, and day 3, we finish those 3 events. So what about the day 4? On day 4 we cannot finish this event because this event is from day 2 to day 3. So this means we can only finish the 3 events, but actually we can finish the 4 events. Or day 1 we finish this one, or day 2 we finish the second one, or day 3 we finish the third one. But on day 4 we can still finish the last one. So this means our greedy didn't work, even if we sort from the starting time or we sorted from the end time. It will never works. If we sort it for the end time, for example, so this will be, it will be the same. So this will be 2 to 3. 3 is the add time. So for others, let me prepare for other add time. So this will be this will be 2 to 4. Because we are just sorting according to the add time. Or maybe this is 2 to 4. It also didn't work. It's not always work. So this is 2 to 3. So we are just sorting according to the add time. So it means on day 2 we can finish one job, this one. Or day 3 we can still finish this job, second job. And on day 4 we can finish the third job. So this is the right situation if we are sorting from the add time. So if there are more, let me prepare the similar examples like this. So for the start time, so what about 2 to 5? If 2 to 5 or day 5, we can still finish this one. So what about 3 to 4? What about 3 to 4? So it's a similar example. So if there are a lot of events from 2 to others, a lot of events, actually it can finish. It can finish. But in this case, if there are a lot of 2 to maybe 5 or 6, a lot of 2 to 6, in these areas, a lot of from the start point 2 to 6, and this is 3 to 4. This means you will miss this event because you are sorting it according to the end event. yeah, if this end event is from 3 to 7, yeah, so this is the start. Yeah, it's a similar example. For example, this is a 1 to 6 sorting according to the add time. This is also 1 to 6, and there's another event 1 to 6 sort according to the end time. Yeah, maybe there are more than maybe 6 or 10 of event like this. And here we have another event. It is from let's say it's from 5 to 7. Yeah. Yeah, let me make it 5 to 6. If there's another event, it is 5 to 6. So this means for the event, when you are finishing this event from the day 1 to day 6, this one, this one, this one, when you are finishing this event, you may miss this last event. Yeah, but it's still an opportunity to finish. Maybe this is from 1 to 7. This event are always 1 to 7. Yeah. And on day 1, you finish 1, day 2, or day 6, you finish the 6th event of 1 to 7. Yeah, what about day 7? On day 7, there's no event you can finish because you missed this 5 to 6 because you are sorting it according to the, this is a 5 to 7 maybe. Yeah, you are sorted according to the add time. Yeah, so actually, how should we solve this problem? We should consider the start date and also the add date together. Yeah, this is why this problem is difficult to think. Let me just prepare another drawing. So now we are going to consider this problem like this. So this is our day. So if we have day 1, so this is day 1. So what about the event? So which kind of event we should to finish first? It should be according to the deadline. So if the deadline is just earlier, yeah, we need to finish it. For example, so this is my day. So this is day 1. Yeah. So for day 1, it is here. So this is the event. So if the event start time is less than this day, like this, it means this kind of event we need to finish first. Yeah. So this is the start time. This is the end time. It is always before this day 1. So for example, so we can prepare this event and put it inside a heap. So this means we are going to sort the array according to the start time. According to this start time, so this is our event. So if the start time is less than our day 1, so we are going to loop through day 1, day 2 until 10 to the power of 5. Yeah, but for this day, we just sort this array event first. If it is before the day, the start time, we are going to put it inside a heap, inside a min heap. In the min heap, what values we need to put is only the add time. Yeah, we are going to put this add time inside our heap. So inside the min heap, so there will be a lot of add time. Now we are going to pop out the add time first. Which kind of event we can pop out? So if this add time is even before this day, it means it doesn't matter. We will not choose. Yeah, so we will pop out this kind of event. Now we are going to check these two events, this one and this one. So for this event, the add time is earlier. Yeah, but it is still, we can finish, but this event we can still finish. So we'll finish this event first. Why? Because for the next event, maybe day 2 is here. We can still finish it on the next day. So this is why we need to finish the event according to the deadline. If the deadline is earlier, we always want to finish the event. It's like when we are doing the assignment. If the deadline is earlier, we should always finish the earlier assignment. Maybe next day we still have time to finish the next assignment. Maybe that is later. Yeah. Now let me go to the code editor to finish the coding like this. So I'm going to I'm going to use the English version to finish this problem. Yeah, as I explained earlier, first of all, I'm going to sort the event array. So the event should be sorted according to the starting time. Now I'm gonna prepare some variables. I'm gonna prepare a min heap should equal to an empty array, and I also need to prepare the result. So the result would be as 0, and I'm going to prepare a day because day will start from day 1. And then I'm going to prepare a pointer I. So this pointer I is for this event array. Now let me check. So while day less than and equal to 10 to the power of 5. So this is given according to the problem. Yeah. So I'm going to use it continually for all the days. Yeah, because the 10 to the power of 5 is not a big number. Even it is n times log n time complexity, it is still okay. So this is why I'm gonna use 10 times 10 to the power of 5. Yeah, if you can also put it use the separate values inside the array. Yeah, but this is still okay if I use a continuous days. Yeah. So finally, the day should be updated by 1. Just need to jump out the while loop, and my result will be the final result. So inside, I'm going to check the event. So for this I pointer, I index, while I is less than the length of the event. Yeah, while I is less than the event, and also I need to check the day. If this event, for I less than event, it means I have events, and also I need to check the events. So for the event I with the start time, if this start time is less than or equal to my current day, it means I can put it inside my heap. So I will use a heap push with my min heap, and with this event I, and put it inside the add time. So here should be the start time. I made a mistake. So yeah, if the start time is less than or equal to this day, it means I can always put it inside. So it is just like here, the examples from here. This is my day. If the start time is less than or equal to my day, I will put this 4 event 1, 2, 3, and 4 inside my heap. After that, I will pop it out according to the conditions. Yeah, like this 2 event, I will pop it out, and this event I will take it into my result, and I even pop it out. And then I go to the next day, day 2. Maybe this event is also possible. Maybe there are also some events I can put it inside my heap. Yeah, now let me continue. And while I can put it into the heap, so the I index can be updated by 1. Now I'm going to check. So while there is a min heap, yeah, I'm going to check if there's something inside the min heap, and the min heap 0, it means the smallest value inside my min heap. Yeah, if this is yeah, it is the add time. If this add time is less than the day, it means I can pop it out. So I can use a heap pop with my min heap. Yeah. So this just means some kind of the events I can like this. I can like this kind of events. I can put it out because it doesn't matter. Yeah, I only choose this event. So after I pop it out, I will check if there's something inside my min heap. Yeah, if something inside the min heap, so the min heap can pop this value. So this is actually the event I attend. Yeah, while min heap, I can use heap pop with this min heap, and then I'm gonna update my result by 1. Yeah, so actually this is the entire code. Now let me run it to check. Yeah, I still need to define another variable I as 0. Now let me check again. Yeah, as you can see, it works. Now let me submit it before I analyze the time complexity. Yeah, as you can see, it passed, and it is still okay. And the time complexity is n times log n, because this is a while loop. Inside the while doesn't matter. It didn't make any influence. Just pop out or heap push from to the min heap or pop out from the min heap. That is log n time. So this is why the time complexity is n times log n. Thank you for watching. See you next time.